here to dive into CAD Connections and share how it's being utilized at General Motors. Let's welcome Gerry Hanson, Knowledge Management Technical Specialist, and Darryl Yarbrough, Solutions Architect, both from General Motors, along with Jeff Moffa and Steve Boisvert from Auros Knowledge Systems. Take it away.
All right. Thank you for joining this session. This session I approach with some excitement and some trepidation. Let me explain. I'm so glad Sandalwood was able to present this morning, because you saw with Sandalwood that the knowledge-aware approach is not specific to CAD and CAD modeling. So my trepidation with a presentation like this is people start to get the impression that knowledge-aware is all about, making CAD smarter. And it's so much more in reality. But on the excitement side is, I believe in the title of this presentation, CAD just got a whole lot smarter. I mentioned yesterday that the autonomous application of knowledge is something we're striving for within the knowledge-aware vision. And what we're doing here, what General Motors is going to talk about, and what we're going to talk about when we present our connection to CAD, you will see that the autonomous application of knowledge within digital context like CAD is very much a reality of today, and it's ripe for the exploiting. So that said, let's kind of start moving into the details here. So how does knowledge aware make CAD smarter? What's going on here? How does this work? And one of the ways to explain this is with this model called the knowledge flow model. I did mention that yesterday. I don't have time to explain the full knowledge flow model to you, but I'll give you a very high level version of what the knowledge flow model is. And what we mean by that is in a technical enterprise, processes are becoming model driven. So we call that the model driven enterprise. And to meet the needs of this model driven enterprise, we have a series of flows, and I'm just going to briefly describe them here. Flow down. This is the typical requirements process, voice of the customer. It has a unique way of needs to manage that flow down process. We have the organizational learning processes that we call flow up. This is how we create lessons. This is how we learn how to meet requirements. If the customer needs the car to brake from 60 to 0 in 115 feet, how do we do that, right? How do we size brakes? How do we dissipate energy? All these things. And we have another process called flow in. This is where our suppliers and external organizations may contribute to this process through their knowledge injection. And what we're trying to do with this flow model is to unify these three streams and make them work in concert. And then represent knowledge in a way, here it's called a coherent stream of knowledge, in a way that can be presented uniformly to models that exist and are driving our decisions, driving our workflows, driving our ability to execute, right? And if we can provide a coherent stream, and this is where autonomous knowledge application comes in, we're going to be able to do a lot. And in accord with the knowledge-aware vision, we're going to gather data of what's happening and use techniques, use insights that will enable us to create new knowledge or feed the flow-up process, the learning process again. Okay, so today we're talking about, well, what happens when we have CAD models? So we're going to assume that these flows are working, and we're going to show what happens when a coherent stream of knowledge is presented to a digital environment like NX, right? So regardless of where the knowledge is generated, what community, what area, whether it's externally generated or internally generated to your organization, we can present that to a digital system, and we're going to show you what that experience is like. Okay, so the vision here is for lessons, standards, requirements to inform every model. Again, here CAD, right? So the autonomous, increasing the level of autonomy and how knowledge flows and interacts with digital environments. So So I want to explain the 4 use cases. So we've got quite a bit of experience in this now. General Motors has been doing this for quite some time. We have other major engineering organizations also working on this autonomous delivery of knowledge to CAD. And we have this experience now that we can say there are generally 4 use cases or CAD techniques where this applies. And I think for those that have some experience with CAD, this will be quite intuitive for you. The first one is we call the greenfield use case. So if you were to sit down in front of a CAD workstation and start designing from scratch, there is a certain interaction model that we would deploy in autonomous knowledge delivery. Okay, what does that look like? How does that work? What advantages are there when you're sitting down at a blank screen? The second use case is the highly parametric use case. So sometimes people call these smart parts, seed parts, right? And basically you start with a predefined parametric model and you use the parametric capabilities to drive and check the model. That is a distinct use case. And there are certain ways that the autonomous knowledge delivery will interact with that scenario. The third use case is really the hybrid between, well, I've got some parametrics and I just surface, what do I do with that, right? It's a dumb part. How does knowledge interact with, in this autonomous way with a dumb part? I just need to do something. What value can this kind of knowledge delivery and interaction give? And the answer is a lot, but I'll let Jim and my colleague Steve Boisvert talk about that. And lastly, the last use case is KB. Now, not all of you may be familiar with the term, but there is a long-standing technique of driving CAD through programs, right? Using programmatic programs to loft, trim, extrude, to do CAD manipulations through the CAD system's native APIs to automate design. And that is a distinct use case for autonomous knowledge delivery. Very much an important one for those that are doing KB. It's hard to imagine anybody doing KB on a large scale without having a knowledge-aware footprint to help make that process more efficient. Okay, and I think the GM team here, Gerry and Darryl, will be talking about that. So we're gonna, again, there's gonna be 2 demonstrations, 2 sets of parts of this presentation, which is considerably longer than the normal presentations today. This one's an hour, 10 minutes long. It's rich in content, so I think it's deserving of that time. And I'm over time, so I'm gonna pass that off to General Motors, to Gerry Hanson to start the General Motors part of this presentation.
Hello, everyone. Darryl's hopefully joining me here.
I am. Hello.
Okay. Gerry, you're going to share your presentation. There we go.
Yes.
You're going to start?
Yeah. Before we get started, we'd like to see how everyone assesses their K-Packs currently. So we have a little poll. Are we able to pull up the poll?
Sorry. I apologize for talking with being muted. I had muted myself in the background. So Darryl, what I was trying to say was the poll just went out. And would you like me to read off the results as they're coming in?
Yes.
Okay, cool.
Yes,
perfect. Okay, good. Let me scroll down to where that new poll just came in. So yes, the question is, are you trying to connect Auros IQ to CAD? And I do have to vote. I'll just select considering it in order to see the results. Okay, so we've got so far 52% at yes.
Okay.
That just went down slightly. No, 21%, considering it at 33%.
All right.
Okay.
Great. So Gerry is going to start off with the history and how the process that we're going through has evolved. Take it away.
Okay. Much like Jeff outlined, we started it a little bit backwards. Our initial use of Auros, what was this, Darryl, 10, 12 years ago, maybe? It's been a
At
while.
least
It was
it's been a
called
while. Yes.
E2KS in those days. We started using it with KBE applications first as a back end. What that really means is we configure at launch on the NX side. Auros is accessed by the KBE app. All the defaults, the preferences, messages, menus, anything we want are loaded. Our worst application takes a few seconds. Most of them are very quick. And then we store that on the system as a backup. And unless there's a change in Auros, which we can detect on the NX side, we don't have to re-access Auros again. So every time they launch the app subsequently, it launches a little bit quicker. I think our biggest one is probably whole placement, and that accesses about 350 K-packs through K-sets to configure the app when it's launched. This has worked so well for us that we wouldn't develop any KB application without using Auros as a back end. And I don't know how everybody else's organizations are, but it takes us a while to develop, to test, deploy, and validate software. So if we want to make configuration changes, even something like a layer setting, I want to create a hole on layer 10. If we decide as a company we want it on layer 12, we just change the parameter in Auros, and the next time the application runs, it creates that hole on layer 12. Little things like that. Huge benefit to us. Next, we leveraged Auros with what Jeff talked about in greenfield or blank parts. A few years back when we were meeting live at Troy, Darryl demonstrated this process between a door and a fender. We had K-packs. He loaded them with our connector, and then on the fly built geometry that linked back to Auros. We then developed a standard work process that used parameters added and linked to Auros. This led to what Jeff talked about as fully parametric parts. These are predefined parts with Auros links added ahead of time to ensure that compliance to the criteria. Could be an NX template kind of thing. And then finally, we've really landed on this hybrid approach, which allows us to address several issues and pain points that we had with the existing processes. This is a standard work process to validate math to criteria, engineering best practice kind of things. We validate existing objects regardless of its source. And Darryl's got a pretty cool thing to show you about this. We developed a template file that allows users to select existing math, automatically updates predefined criteria checks, measurements. Then we validate the check with Auros. This existing math can be crude, non-parametric, could be IGES files brought in, and the process still works because of the way the math is re-linked. Okay, next, pain points. Okay, now, Darryl and I have kind of landed on this over the years because we've worked quite a long time on this, is we don't seem to be able to make any successful migration to anything unless we address pain points. As soon as you address a pain point, they start smiling, and all of a sudden they become much more cooperative, right? It's not like people do. We'd like to all believe people do things for the right reasons, but generally it's pretty self-serving. So if we can address that, we're normally pretty successful. One of the pain points we had was that our designers are spending a huge amount of time validating criteria manually, and took them away from designing, which is really what we want them to do. They were cutting sections, making PowerPoints, populating spreadsheets. A couple years back, we migrated the exterior group from checklist-based, Excel-based stuff to assessments. They had designers spending up to 3 days making 50-page plus PowerPoint files, and then sending them to engineers. They said it was absolutely agonizing, and this has helped us get away from that. We also have inconsistent results are provided by design. The best practice can be interpreted differently by each person, believe it or not. So each designer had a different way of making the check. Might be square to grid, might be the closest point, could be anything like that. And different output was given to engineering. Users are not familiar with checks and must constantly look them up. Or worse yet, download a PowerPoint or Excel file to their super secret hard drive, and then they have no way of knowing when the best practice was updated. Parts are out of date when the BP is updated because of that. This happens if there's a change to the BP and the designer isn't aware of it. Could you imagine making an engineer making a change without telling everybody? Engineering must update the peer reviews manually. All of our peer reviews now on the engineering side are done in Auros. If they do use value tables, they must cut and paste into the processor. Typically, peer reviews are pass-fail instead of using actual values and letting the rule processor determine the compliance. Because of this, you don't necessarily know how bad the violation is. Done properly, our value tables can help change our information to explicit, and thus we can evaluate them logically. One approach Darryl and I take now, without exception, is every value table we create must evaluate in the rule processing engine. I think Jeff calls it the knowledge processing engine now. So they're really the same thing. So that's just a little bit of the pain points and the history that we're at. Darryl's going to talk about his stuff now.
So when we were starting out with this, as Gerry mentioned, things were, it was a manual process to get done. So users would manually do these measurements. And you can imagine you have several checks and you're going into the CAD system and you're making all these measurements, and no one wanted to do that. Then they're going to look the information up in Auros if they don't know what it is off the top of their head, but hopefully they would check each time to make sure that it hadn't been changed. They'll look that up in Auros. Then they will capture images of the drawings that they make with the dimensions in there, and then collect it on a spreadsheet or PowerPoint, and then they'll supply that to the engineer. And then the engineer would assess it, and it would generally, historically, have been a pass-fail type of designation when they would assess it. So what we wanted to do was allow the user to select the geometry in the CAD system, and the required measurements and the orientation of the drawings where they're going to do the screen captures are already predefined. And then the file also has links to the measurement directly to the rule checks that are being done in Auros. And this would allow the user to dynamically know on the fly if they're passing or failing. Anyone could go into that file and they would know if they're passing and failing. And then they would snap the pictures, and then authorized users would be able to then go in and write that information back to the assessment to be used in the design reviews, and then post up the pictures to be captured in the line items of these assessments. So our main goal was to reduce the time it takes to do these validations. Once again, the designers are spending a lot of time being pulled off of design work to make these checks. We were going to reduce that amount of time. We were going to increase the accuracy of the check because the intent of the check is predefined in the files that they're going to be using. We would provide consistent output no matter whose file that you would go into. The check would be done in the same manner. So everyone's check, everything that engineers are receiving are going to be the same. And we'll also allow that information to be written back. So no more cutting and pasting the information that's in the PowerPoint into the rule processor, into the knowledge processing engine. That information would be fed directly back. And the nice thing about that is the write back. Gerry can explain that.
Oh, sorry, I'm muted. Okay. The write back, when we talk about write back, we're talking about the designer, when he's done working in NX, writing back to the assessment in Auros. And this would be written back to the engineering best practice assessment, which Darryl will demo in a little bit later. This helps facilitate our closed loop learning back to the Auros database, so the BFO can open these things, open the assessments, and not have to know anything about the CAD file and see what's happening. He can look at all the values for all of his assessments to see how they're stacking up. One of the advantages is if we find out that 8 out of 10 designs are violating a best practice, it's time to consider maybe the best practice needs to be changed, or some other course of action. So this works by first pulling the definition criteria into Auros. In this case, it could be a KSET, it could be a KPAC, it could be an assessment. We allow all three. keep in mind you must have properly formatted value tables that can run in the knowledge processing engine. And I can't um, uh, tell you how important that really ends up being. Because in our process of what we call decomposing PowerPoints and Excels into separate bits into Auros so that we can consume them in the assessment and in NX, these value tables really have to work. We find a lot of best practices with holes. Sometimes they might have a range of 0 to 10 is a warning, 20 to 30 is a pass, and 40 to 50 is a failure. And you start asking, well, what happens if it's less than 1? What happens if it's between 20 and 30? And we find this. So we find holes. And what really having logical value tables does is gets rid of all that ambiguity, right? So we always do that. Value tables have to rule process. Next, we add a link in the parameter CAD model. The knowledge processing engine will allow you to dynamically see and adhere to that criteria because it links them up. And you'll see that when we demo it. Then finally, you can write the reported value from the CAD file directly back to the assessment. With this information, you can form a read across on the parameters like I mentioned earlier. Over time, you can use this information to redefine your criteria and update the link to the future CAD models if the process keeps repeating. So I think at this point now, Darryl's going to go into showing you how he's going to manage this.
Okay, so here I have a template file, and what this is doing is checking for the seat comfort of the trenches. So I'm going to bring in my program information. So I'm just going to slide it over here. And of course, my menus are popping up on the wrong screen. And I can fit, and now you can see the program information. So once again, we had mentioned that this works on crude data. Well, this seat is crude, so I need to go in here because it's just a bunch of surfaces, and I'm just gonna sew all these together so it's a single body. And that's the only prep work I need to do on this. And now I will go in and execute this. So edit reusable component. And what we've done is we've created a template file that takes in this program information as input and then update and morphs the template into the program information. And all of the checks that are built into the template are consequently updated to program. So I want to select the upper leg line, so I can just select that geometry straight off of the screen, select the H point, select that off the screen, and select the cushion. Okay. Hit apply, and then it's going to update my main section. So now I just have to define where the trenches are. So I'm going to select the forward trench location, the rear trench location, and the rear edge of the seat. And say okay. And now all I need to do is go into the layer settings, turn on the criteria, the section, and turn everything else off. And once again, we had these predefined camera views. So go to main and fit, and there we go. So my only cleanup is just to make it so these dimensions look good. Done. And now I can scroll down and I can see that this parameter is violating. If I double click on it, I have direct access to the KPAC. It's a maximum of 180, and I'm actually at 302. And so I have all this information available to me. I can go in here and look up the Auros link, and it brings up the entire case set, which has all the information, the 4 parameters that are in here. I can see the image, and I have all the information available to me So now all I need to do is just go in and snap a picture, and I can provide that to the engineer for the design review. On the Auros side, what we've done is we've organized this information. This process has had us look at the information, and Jeff had mentioned earlier, looking at it from the perspective of an assessment. Because we're validating something and we're assessing it, and this was built for that, we were organizing the information and creating the information from the perspective of an assessment. So we can go in here and I can say, I want the check for peer review 2 for cross car, trench, and search and build grid. And it provisions and gives me all of the things that I need to check for that. And with this, I can then create an assessment based off of this information. So we have the assessments already predefined, and I can show you what the write back would look like for that.
Do you need a number, Darryl, or do you have it?
Yes, give me a number. So I'm going to launch parameter manager, and this parameter manager is our connector. Yeah, go on, Gerry.
Right. So as a BFO, I'm going to have built this assessment, and I'm going to give Darryl the number because it's got other checks rather than just the design stuff. So in this case, I'm going to have him load 300-218.
218. I want to continue. Now, if I go, did not mean to do that. If I show the
live demos,
yes, you can see that everything's blue. It hasn't been evaluated. So now what I'm going to do is I'm going to write to assessment, and just that quick. Now I'm going to show assessment, and you can see, here we go. And now I can go into here, and let's see if this part works. Where's the one that was red? This one. And there we go. So now it's tied to my line item, and I have all the parameters from my CAD model inside of the assessment. And now this can be reviewed during the design review, complete with the evidence.
Now, just for fun, Darryl,
yes.
Launch the rural processor on that assessment really quick.
Sure.
Show it. Yeah, drag it back over.
This, which one? Do you want me to launch?
The assessment you had up, the red line item. Yeah, just launch that, and then pick the number when that launches.
Oh, yes.
Knowledge process, and then pick that. Now, what this is a read across. Now, this is just a couple of assessments, but you can see we've got one dot at the top and one dot at the bottom. As the engineer populates these, or the designer populates, we get the benefit of these read acrosses for that common parameter. So parameter names are important, right? They have to match and be consistent. So you can close that. That just was an idea of how we use the data, right? How the data can be used.
Yes.
Quickly, accessible by the engineer. So.
And what this enabled us to do was to take this process, which would take several hours for the designer to do, and brought it down to minutes. And using a system that we were able to set up relatively quickly and add value to the engineer, to the designer, to both groups simultaneously. So,
yeah, there was something in it for both of them, so both groups were interested. So
yes. Now, to do this is not free, as far as there's certain requirements that need to be done on both the Auros side and the CAD side. On the Auros side, you'll need properly formatted value tables that can be rule processed. These value tables will have to have valid parameter names, and the parameters will have to adhere to the constraints of the CAD system. So if you have meters multiplied by meters, your value has to be meters squared. You can't have a parameter be for an angle, but you're feeding it into a length parameter on the CAD side. The naming convention of the parameters have to be correct. For NX, for instance, you can't start it. You have to start it with a string, not a number. No special characters, no spaces. So make sure you are adhere to that. On the NX side, you'll need associativity turned on so that your parameters can be linked to the actual features in the CAD model. You'll need, in our case, we had a template created with predefined measurements and the checks built in, and then we just reparent the features and everything updates. And then you'll need some type of rule checker, some type of linker. In our case, it's parameter manager to link the Auros data to the CAD model.
Okay, we'll wrap this up with just a quick review of the benefits. The big deal is we get active links in the CAD model accessible by the designer at any time. You just open the file, and you saw in the feature navigator how we had the features with red, yellow, green, those kinds of things. We have dynamic checks that are live and that allow you to check the status on the engineering side too, so he can look at the data. The file, in this case, Darryl has predefined views that enable you to snap an image and provide that for the design reviews. The results are reported using a standardized format, and the assessments in this case, we didn't show you the header, but there would be a bunch of different program information. And much like Darryl found peer review too with some other stuff, you can find any assessments by program and those kinds of things. Standard Auros filter stuff. We can write the output directly back to the assessment, eliminating the need to cut, paste, emails, all that kind of stuff. And then of course the output is criteria compliant, and the part is consistent between users. So those are some of the benefits that we have seen using this process. That's it for us, I think.
Well, one thing is to get all together, it's going to save time.
Yeah.
That's one of the big things. We're saving time on the engineering side, we're saving time on the design side. And the other benefit is that we're increasing accuracy. The checks, because the checks are consistent, it's predefined using the intent. It's going to be accurate. And because we're using live data, that's the latest information, the most current, it's going to be accurate that way as well.
And it's pretty fast. I mean, we don't really see any latency in checks back to Auros. No. Things are pretty speedy. So, all right.
I think it's back to Jeff or Steve.
All right. Hey, Darryl, Gerry, thank you so much. The progress you guys have made is inspiring, and as you guys know, but for everybody else's sake, Auros and Gerry and Darryl, we continue to communicate to push the envelope on how to make knowledge autonomously connect to CAD. It's taken a long way, and now I am happy to share the commercial version of the connector that I believe represents, at least from our perspective, the next generation and how this works. So here, Darryl and Gerry went through all 4 use cases. I'm going to have my colleague, Steve Boisvert, join me, and he is going to take us through a demonstration of use 1 greenfield if there's time. we're going to concentrate mostly on the highly parametric use case. Just because Darryl and Gerry didn't show that as much. So the connector that Steve's about to show, he briefly showed yesterday in the advanced session. This is the next generation CAD connector. The NX version of it will be available in the next month, and we do support multiplicity of CAD systems. So you're seeing the NX version today, but there are versions for other CAD systems and virtually any CAD system based on request. So with that, Steve, can you go ahead and take away the unveiling of the new Auros NX connector?
Absolutely. Thanks, Jeff. Gerry, Darryl, this stuff is really cool. I'm always impressed every time you demonstrate it. It's pretty cool to see these real world examples play out, especially for our audience here. It's fantastic work you guys are doing. I know though from going through your presentation before, like if you're in the audience, that stuff might look complicated. I mean, it can seem kind of overwhelming. Like that's a lot to take on and a lot to try to comprehend and try to achieve. But I'm here to tell you that it's really not. It's when we get down to it, it's really just about managing parameters. And that's kind of the whole point of why we're following up with the demonstration that I'm going to do today. And it's kind of bring it back down a level and kind of show you that, you know, it doesn't really have to be all that complicated. And the stuff they're doing is great for their workflow. It might not be for your workflow. And that's really kind of what I'm going to try to explain here. So for today, I'm going to do a demo. And like Jeff mentioned, I am going to use our newest NX connector. Like you mentioned, we were planning on rolling this out to all of our other connectors in the near future. This one's going to be commercially available roughly at the beginning of November. I'd say we're about 60, maybe 65% done with it. But it's enough for us to kind of go through the concept today. I'm going to be using my cool cup. So we talked a little bit about this yesterday. If you're in the advanced session,
Oh my God,
we have this cool cup kind of concept that we use, and we like to use it because it's simple. It's going to be a very simplistic demonstration today, and you're going to see how the features work. And you're going to be able to compare and contrast what Gerry and Darryl are doing with the parameter manager to the Auros kind of out of the box connector. They both basically accomplish the same thing. You're just going to see it in a little different light. So let's kind of dive in here. So so you can see I have NX open. I have my cup. It resembles a Turvis tumbler because that's what we based our model on. So it's an assembly. It's two parts. I have an outer and an inner. For today's demonstration, we are just going to focus on the inner cup. So let's turn the outer cup off just to make it a little clearer here. So as I did yesterday, I want to start not with the model. I want to take you in and show you the knowledge, show you how we've constructed the knowledge packets, show you the features that we wanted to validate or drive inside the model. And then we're going to come back into the NX connector, and I'm going to show you how those things connect. So with that, let's hop over into Auros. So you should see my Auros landing page come up on your screen. So these are our smart tiles. And where I want to take you into is we have a community of practice. You've heard a lot about communities of practice. It's kind of where your particular knowledge is stored for a particular workflow. And for this demonstration, I have a product engineering community of practice for CoolCup. And you can see I have several knowledge packets. Each one of these rows represents a knowledge packet. If I open, one of these up, we can take a look at an example knowledge packet. So for this example, it's talking about the inner wall thickness and a distance. Each one of my knowledge packets does have a value table, which Gerry and Darryl talked about. It's extremely important that we model knowledge in this fashion, that we can provision that knowledge into other applications like NX for our demonstration today. You can see on this one, this inner wall thickness has a minimum criteria, right? It says minimum wall thickness 1.5 millimeters, and then we have this parameter, inner wall thickness distance. And that is the portion of the knowledge packet that gets actually communicated across to the other application. And when it's in the other application and it's being used in that other application, the knowledge processing engine is aware of how to process that, any kind of information or values that are connected to that parameter, and provide a response. And we can see that in this view, actually. If we click this little lightning bolt, we can test that. And we saw Gerry and Darryl do the same thing. You can test the value of the model of within the value table. So if this is looking for a minimum value of 1.5, if I have this connected in the CAD model and my wall thickness is 1, what will happen is the knowledge processing engine will compute and it'll tell me, hey, that's not correct. You're failing this criteria. And because it's a minimum, if I have anything more than 1.5 and I reevaluate, the system's going to tell me, hey, that's good value. The design's correct. So this is a very important concept of understanding how to capture knowledge, create these value tables, and we're actually going to create one today. And we're going to put it back into the model as I get into the demo. But an important concept to understand how the rule processing engine interacts here. For our demonstration today, typically what we like to do is gather context from a model and say, oh, you're working on the inner, it's this type of material, it's maybe this size of a cup. Detect that context and then provision those knowledge packets to the model. In this case, our connector isn't complete yet. There's still some functionality we're working on. So I'm going to shortcut that process, and I'm going to show you how I'm going to do that. I've created a set. Actually, Jeff created a set for the inner portion of our cup, our cool cup here. And this set here understands which knowledge packets I want to collect and which ones I want to provision into the model. So my inner part set is comprised of 6 knowledge packets here. You can see they all have value tables that kind of vary. And now that you've seen the knowledge that we're going to apply, you can see that each of these have parameters, value tables. Let's hop back into the model and look at what's going on inside of NX. So hopefully you see my NX model. I still have my inner cup model on the screen. So like I mentioned, it's 2 parts. One thing I want to point out about my inner cup, if we click on the little part navigator over here, we can see my modeling history. And one of the things I want to make perfectly clear about my demonstration I'm going to do is I've already embedded some parameters into my sketches. This is pretty common practice when you're designing. If you want to control certain features or measurements, dimensions, or you're going to have to manipulate those values often through the design cycle, we typically will name those. That way they're easy to get to, they're easy to change within in the case of NX, in the expression editor, basically it's the parameter manager within the tool. But as you can see here, I have one named inner bottom cup OD, which happens to match one of my parameters that's in the knowledge packet. And that's important to understand because as I start to use the connector and as the parameters from Auros come into my NX model, it's going to say, hey, you have inner bottom cup OD in the model. Your knowledge source also has inner bottom cup OD. They're going to bind to each other, and it's going to start to rule process automatically just by having the name for the parameter inside of my sketch. And you can see I've done a couple of my other sketches. So that was the first sketch. In this sketch, I defined my inner weld flange width and my inner weld flange height. Just key features within the model that I want to control and I want to validate. So there's no magic when I open up the connector and I attach it to the knowledge and things start to evaluate. It's not magic. It was by design. And here's kind of under the hood of how that happened. So with all that, we have our model. I showed you my sketches, some of the parameter names in the sketches. Now we're going to go and we're going to connect knowledge into the model. And for that, I'm going to open up our out-of-the-box Auros connector. That's available, will be available as of November. So I'm going to click on my little icon within NX. It's starting to open the connector now. And it's kind of going through a few things here I kind of want to point out to you real quick. The first thing that it did is the connector went and said, who's driving this connector? And it actually knew who I was. And it authenticated me. And it also looked to see, all right, which instance of Auros do I want to connect to? Where's your knowledge? And you can see I'm connected to my demo instance here. The second thing that it did is it looked to see which part are we connecting to. Like I mentioned, this is an assembly. I could have connected to the assembly level, the outer part, and in this case, because I had the inner part was active and it was my active work part, it already knew. It said, all right, I'm going to connect to the inner cup. And so that kind of happened in the background that when we didn't even see that happen. The third thing it's asking here in the setup is, what's the knowledge source? Now, ideally, like I mentioned, we would put in criteria. You know, it's an acrylic tumbler, it's this size, and then the knowledge repository would provision the right knowledge packets in here. Like I mentioned, we're going to kind of short circuit that. We're going to just say we're going to use that set that Jeff predefined, 1365, and we're making the connection now from the CAD model through the connector to Auros IQ. So what just happened? So the connector went off, said, all right, I found that set, that knowledge packet set that you've predefined. And here's what I know about that set. There's 6 knowledge packets within that set. 3 of them are design standards. 1 of them is a functional requirement. 1's a manufacturing standard, and 1's an ergonomic standard. So it's providing a little bit of insight to the designer about what type of knowledge are about to apply into the model. And it's also showing me that from these 6 knowledge packets, there's actually 9 evaluations that have to occur, which is really important. So and we're going to see how that happens. So I'm going to say, all right, good. I'm going to close that, hit apply. And now it's bringing in those parameters from the knowledge processing engine from that set, and it's attaching things into the model. And you can see, automatically things start happening. I have some red, yellow, green criteria here shown in my NX connector. And in the part navigator, similar to what Gerry and Darryl showed you, we have visual indicators of compliance in our part navigator. So in our newest NX connector, you kind of see here, we're keying in on the conformance, or basically the qualitative response from the knowledge processing engine here. We want the designer or engineer to be completely aware of what's going on with their the interaction between parameters in the model. And so for that, let's kind of get in to see what this is doing. Kind of see in the part navigator, we have all these reds. So let's start there. Let's start with the red items. Maybe we want to address these first. So I'm going to click on the red portion of the chart, and that's going to expand and show me what are the parameters that have an issue. So I can see there's an inner weld flange width, the inner weld flange height, inner lip radius, reduction length. And excuse me, if I expand that, I can see what's going on with them. Actually, I can see, all right, so the inner weld flange width, in the model, I have it set as 4 millimeters. But based on the rule that I've defined in my knowledge packet, and if I want to see that rule, I can click on this knowledge packet link. I can see the rule. I can see that, all right, by design, I have a nominal condition where my inner weld flange width should be 2 and my inner weld flange height should be 2 millimeter. So according to the rule. So with that in mind, hopping back into NX, and I can see all that happening. I can see that in the connector. It's telling me your value is 4, but it should be 2. And I even have an end user message that's telling me, hey, your value is 4, but it should be 2. So if we kind of go through here, we can see that play out again with the weld flange height, like we discussed. We can see the inner lip radius is set at 1.5, but it should be 2.1 to meet our criteria. And the inner rib OD reduction length is at 1.5, but it should be 1 according to our connector and the knowledge that's being provisioned into the model. So let's address these. So I'm going to click this little edit, and it's going to take me to my parameters inside of the connector. And I'm going to address all my red conditions. Based on the value that we saw in the knowledge packet, the weld height and width should be 2. The inner lip radius should be 2.1, and the reduction length should just be 1. And so we are going to make those changes. So I'm going to change the values inside the connector, but I'm going to submit those values back to the model. So what's going to happen is the new values that I just put into the model are going to change the geometry that is shown in my modeling window. So those values are getting pushed into the model. So the geometry is going to update. And those values are also going to go back to Auros to be revalidated and rechecked. And so what we can see, I do have a warning. That's okay. And let's open up our connector. So I made the changes. Looks like I didn't quite get one right. And let's kind of look at that inner lip radius. This one should be 2.1. I set it to 1. This one is 1.5. And all right, so I need to change this. Smaller than 2.1. All right, so we're going to change this value. So let's change it again. We're getting everything green. 2.1. And we're going to change that. All right, so now that value is going to update. We're going to get our green condition, and then we'll just have a yellow condition to worry about. So the model updated, geometry changed, the new values got processed by the knowledge processing engine. I can see in the part navigator, things are starting to turn green. I can see in the connector, things are starting to turn green. I still have one yellow condition I want to deal with. It's the inner bottom cup OD. We're going to check this one out. It's telling me that I have a condition where, it's set to 35. I should be larger than that. So we're just going to change this value to 50. I'm going to submit that change. The model, again, is going to update. We're going to see this little area at the bottom of the model change. It's going to make all of our rules happy, and things are going to turn green. So our model's happy. We're in compliance. Everything is good here. What happens if something is created? What happens if new knowledge is created? We get that question all the time. Or what happens if a value changes? And so I just kind of want to hop back into Auros and play the role of an author real quick. And I'm going to show you how the part inside of NX updates. So let's kind of go back in. Let's look at all of our knowledge packets, and let's create a new one. I'm going to create a new one real quickly. So we're going to create a new best practice. And I'm going to show you how easy it is to create a knowledge packet. So we're going to say this is going to be minimum rib height. And I've learned something about rib height. I'm going to give you a quick description. Same thing. Do it quickly here. So we have a title, minimum rib height, and we need to create that value table. So to create the value table, we have a little wizard that opens up. We have to give it a quick column name. So I'm going to name it the same thing I just did, min rib height. And we are going to say the minimum rib height needs to be what? And I'm going to say it's 1.5. 1.5 what? And it's going to be millimeters. Millimeters in length. And then the important piece, we need to give it a parameter name. Right now, it's a default system name. I don't want to use that name. So we're going to open up the parameter name editor, and we have a little wizard here to help me name it correctly. So I'm going to call it the inner rib height. And this is actually a length measurement. So we have inner rib height, and it's actually going to be inner rib height length. And we're going to save it. Actually, let's give it a message. So if anything goes wrong, that we are communicating back to the designer why that's wrong. So I have a value table. I have a description. Now I got to define a few things. What is this for? It's for the acrylic type of tumbler. It's a core function. It's for the inner part. and it's a CAD check. So I'm applying some metadata to my knowledge packet. I'm going to make that active. Then now that it's active, let's take a quick look at it. If I do a list all, we have our rib height, minimum rib height down here, rib height length. Let's open back up our connector. Quick refresh. And now it's going back to Auros looking for new knowledge. And I goofed up. Now what did I do? Did I save it? So let's change that. And then one other thing I do want to change, we're going to change a value inside of a knowledge packet. So let's change our where did it go? Right here. We're going to change our weld flange width real quick. So just two quick things. So let's say this also changed. Now it's the value is no longer 2. The value is now 3. Right, we're going to make both of these changes. Update the model. Save those changes. So the rule changed. We're going to come back into the connector, refresh it, and now we'll have those values get revalidated against the knowledge. And now they're no longer green because I changed the value. Now they are red. So one last thing, let's look and see what I did here. Minimum rib height. Yeah, we're good. It should be in here. I don't know. It's the Murphy's Law, something that's goofed up. It should actually, that one I created should be in here. But anyway,
Steve,
that's how.
Did you see Joe Best's comment just now?
No, I haven't.
She wonders about missing the type of minimum in the value table.
Oh, she is so right. I didn't set that.
Cool. Okay, awesome. Thanks,
That
Joe
is
Beth.
why. Yep,
All
that is exactly it. I didn't set it. So let's hop back in there. So we're going to change this. I didn't define the type. And for my type, I'm going to set it to be a minimum. Thank you, Joe Beth. That is exactly what's going on. All right, now I can save this. So it happens you get going a little too fast. All right, so my model or my knowledge is now in. I have a type. We're going to come back to our connector that I must have closed. And now, thank you again, Joe Beth. I get a warning. There's a parameter not found. And so if I look at that parameter, here's our inner rib height, the same one that we created. So I'm actually way over time, and I'm going to turn it back over to Jeff, but that is our new NX connector. And you will see that if you're a current NX connector user, you will be seeing this in about a month.
Okay. I was on the wrong tab. to be the presenter, but I'm back. All right, thank you, Steve. What you should have noticed in that presentation with what Steve was doing was how dynamic the relationship is between the CAD model and the knowledge base. They're really completely abstracted, and the knowledge can change or be added to or removed from, and the model itself could change in any way. And this connector is continuously and autonomously applying to the extent possible the base changes. Okay, so that was the use case. I think we have a bunch of questions for General Motors that we want to get through. Is that correct?
Would you be asking me, Jeff, or the
I would.
gentleman?
Amy, do you have access to those questions? If you
Yes.
do, that'd be great if you could ask them.
Yes, I do. Well, first of all, we have one that came in. We have a few different methods of getting them. The one that I see in the chat first is Scott, and he's asking, is it safe to assume the other CAD connectors look and work very similar to the NX one?
I will take that. To the extent possible, yes. They share about 85% of the code. So all the processing, this is the beauty of the abstraction of keeping the knowledge base from the CAD system separated and talking through a common abstraction. The parts that are different are the way that each of the CAD systems handle expressions and relations. And it's a modest difference at best. They all have parameters, that's straightforward, but then CATIA has relations, NX has expressions, and there's a little bit of peculiarity there, but the interface, that ring chart that, at least in our version of the connector, is identical for each of these systems.
Okay, very good. And if you do have other questions, please type them in the chat window. I've got some here. Is this process difficult to set up, would you say?
Darryl, Gerry, do you guys want to join the stage and see if you want to take a shot at that one? Is it difficult to set up?
Yes and no, right? Oh, I can't hear Darryl. Darryl, are you muted?
Oh. I am. Sorry about that.
Go ahead, Darryl. Go ahead.
So we mentioned the 4 types, and I will talk about the hybrid. That is the easiest to implement, and it provided the best bang for our effort, because with the greenfield and the template, it's predicated on modeling technique and having the designer do things in a specific way. And I know at GM, sometimes designers don't design in a parametric way where parameters can be used to do anything. So you'll have to start cutting sections and doing measurements after the fact, which no one wants to do. With the hybrid approach that we used, we were able to take data regardless of its source, even if it came from another company, and implement it that way. And we were able to set that up extremely fast, quickly, and get the CAPEX updated quickly. And everybody was able to, was willing to buy off on it because they were all getting something out of it, which was something that we struggled with the other methods, getting everyone to buy off on it because it benefited one group and not another.
I would say that we are learning. We're still at a steep part of the learning curve on this. The technology has matured. The technology works. It's compelling.
It does.
But organizing people and getting them to think about the CAD, either when you're driving or checking CAD, there's 2 very different kinds of directions of knowledge flow. You have to kind of get your mind around it first. It's getting shorter and easier rapidly. I personally believe, and I have obviously biases here, that this next generation of connector, in the way that GM has done it as well, in terms of solving certain problems in the hybrid case, solves so many of the problems that have slowed us that we will be very much faster presently.
And one we know more now than we did before. And from a business process perspective, we did not know how to present this. So we were providing information to groups that weren't able to understand what it was we were trying to do and how it would benefit them. But see, now we know more. And so we know,
the lump
okay.
so everybody else won't have to.
Yeah.
The one other thing, Jeff, is that our experience shows that initially BFOs, at least on the GM side, wanted kind of big value tables to make it look like what they had in Excel and PowerPoint.
Yes.
And you want to break your value tables down into smallest bits. Now, if you notice Steve's presentation and you noticed ours, our value tables had one parameter. Okay. That allows us to use dynamic case sets to filter and create assessments on the fly. Okay. And as K-Packs, and you saw in Steve's case, as he added that K-Pack, the case set just picked it up and added it to the assessment. And we do that all the time. We live and die on that dynamic case sets, picking up the extended elements on these individual K-Packs so that we can reuse them effectively and efficiently. So that's part of something you really need to think about if you're going to go down this road. Simple K-Packs, simple. And on the NX side, now just one last thing, and not everybody might understand this, but I explain this to designers because in GM many years ago, when we migrated to NX away from CGS, we went down this one part per file approach. So you would never, there's one part number in our database for a part that only exists ever once, and we just use it over and over and over again through an assembly structure, right? So in Auros, Darryl and I are constantly preaching, we want one K-Pack that's that bit of information, and we just I'm going to use Jeff's term, provision it over and over and over again, okay? So those are the thought processes you need to, as any of these companies going into this kind of thought, this kind of avenue of linking things together. Small bits reassembled.
Good. Very helpful, I'm
That's
sure.
it for me, sorry.
Jeff, do you have something to add before we jump to that next question?
No, I do see Jeff Dempsey's question. Should I just head for that? So
Please,
will this work with Innovia as well as CATIA files delivered are authoritative for the item being manufactured? So this question brings up a lot of questions in my mind to answer it thoroughly. So in the case of NX and Team Center, for which I have far more experience, it does. It does connect back, because the assessment that Darryl showed you that gets created as a result of connecting knowledge, this persistent of statuses, of parameter states, of data history of what parameter states went through, is stored in the assessment. The assessment is tied to objects in PLM, in BOMs, in different object types. So if we're talking about that, then the object types in Innovia, whether it be a BOM object or some other kind of object, can have the Auros assessment tied to it in a way that then is connected. Now, when you say will it work, you mean a lot of other things beyond what I've just described, in which case I would have to have a separate conversation with you to fill that in. Can I throw my question in now?
Sure.
I'm going to throw my question. Why are the GM and Auros connectors different? So I'll say this to start off. They're not. They're not that much different. They look different.
No, they're not.
But Darryl and Gerry have been working on this stuff for a long time, and they've provided a tremendous leadership in, they've got users, and they're talking to people, and they're solving the problems minute by minute, adjusting minute by minute. And the GM connection has evolved continuously, right? And it shows. What we did recently, and one of the things I'm excited about, is we abandoned sort of our previous connector. We didn't abandon it, but we said, okay, we've learned so much. What will we do differently? Now that we've learned this, how would we do it? How do we make it more efficient, more intuitive, more effective? And what are all the use cases that need to be handled, and what are the things that, where automation needs to happen to have autonomous knowledge provisioning and knowledge application in a CAD system? And we finally felt like we were at the point where we could do that. So our product is just, as Steve said, we haven't even launched it really. It's a month away, but it's brand new. So I'm hoping that, the General Motors innovations that are there and the Auros innovations that are there, that we can cooperate continuously or even integrate. What do you say, guys?
Yeah.
Well, yeah, you got to remember we did ours 5 or 6 years ago, right? And we really haven't changed the interface, and we learned a bunch, and we've shared a
I
bunch
think
with
it's
the
more like
residents.
10.
So it might have been, I thought it was 6, but it could have been more than. It's been a long time, and it's taken a long time to us to get the organization emotionally ready. But yeah, I think if we could have, I like what Jeff's got going on in his, the pie chart thing's pretty cool, being able to
Yes.
pick on the reds, much like you would in an assessment. If you're in an assessment control, you can pick on the conformance states on the left, and you can get rid of the ones you don't need. That's pretty cool. We'll have to see, and maybe work together and combine them and come up with one, but one is probably the best choice, I think.
I think so.
And then we have one more question that Tim has.
We'll definitely. I have one final thought, if you don't mind. So my final thought is, we may be interested in this CAD connection and automating, evidence gathering, automating driving parameters, making KB more efficient, all these things that come out of it. But if you step away and think about what's really has been proven by what Gerry and Darryl has done, and what I hope you see is proven, is that you can remove and separate efficiently the knowledge and the model. And when you do that, all kinds of good things happen. And it doesn't matter what model it is. It doesn't matter CAD system. It doesn't matter if it's a BOM. It doesn't matter if it's a process model. Certainly you saw a little bit in Spirit Aero Systems and Darwin's presentation as well. That our ability to do this is a new frontier for getting better results in the future in engineering. And this is what Knowledge Aware is about. This is one pillar of Knowledge Aware, this autonomous application. It's not the whole thing, but it's a compelling part of it. And the proof is now there that it's going to be almost unthinkable not to be managing knowledge in a way that is prepared for digital environments. The document SharePoint approach, it's a dead end. I think it's beyond a discussion anymore. We've gone that far.